Welcome again. Now I come up with a new story, and the story is the boy want to throw a ball here. Okay, want to place the ball here, but he is not willing to move from this position. He is not willing to move from this position. So what he have done? He just throw it. So the ball is moving somewhere like this and reach the aim. Okay, so this type of movement, that is, he throws it and after that it reach there, he is not moved up to here, that is, it is not this type of motions of him, and he also here not moving this or throw this ball upwards, it is not this type of. So what I have considered, that when he is throwing, he is making an angle alpha with the horizontal. Let us consider this is the horizontal level, and basically when I am taking any kind of motion along the horizontal level, I want to discuss any kind of motion along the horizontal level. At that time I say x-axis, I consider this thing. So this is, we can say, it is the aim. You want to throw this aim. So when the particle is thrown, not only that, if I say it is the point of reference from the point of view is observe this thing, from here it is throwing, it is, I can consider it is the origin, but actually the motion of the particle is observed by an observer who is somewhere here. This is the observer, and this boy is a thrower. So I have drawn this axis to analyze the vertical motion, that is the y-axis. The observer is somewhere here, the boy is not the observer, but here I choose this is the point of reference from where it is throwing. So if we throw this thing with an velocity u, if I say it is the initial velocity that is u, then this initial velocity has two components. You know the vector along x-axis, the initial velocity has the component, we can say it is the u cos theta, and along y-axis this initial velocity have the component, that is uy, and we can say it is u sin theta. So u has two components, vertical component which is analyzed by the y-axis, and that is uy, it will be u sin theta, and the horizontal component, that is ux, it is the u cos theta. So there are two things. So obviously two types of motion is performed simultaneously at the same time. Two types of motion is performed, but the effect is one, the particle is moving along this direction. So you can say it is not the independently, it is the horizontal motion, nor it is the vertical motion. Both of these motion occur simultaneously. But in case of analyzing, we can analyze it separately. So that will help us in doing the calculations. And each and every point on this path or the projectile, the acceleration due to gravity, that is A minus G, is acting downwards. Each and every point it is acting downwards. Okay. So the question is, if it is acting downwards, acceleration due to gravity is acting downwards. Now, which component does it affect? Is it component the horizontal? Is it affect the horizontal component, or is it affect the vertical component? That we have to understood. One thing I want to say, here is a vector. If it is a vector capital A, then its perpendicular component along these directions is 0, because it is A cos 90 degree. The vertical component of this vector is A cos 90 degree, and that is 0. So obviously, the acceleration which is acting downwards, which will not affect this horizontal motion. So u cos theta is remain unaffected by the gravitational pull or attraction. But the vertical component u sin theta is on the same line, so it will affect it. So I want to write down this thing, that is the horizontal component will not be affected by g, that is the acceleration due to gravity. If it is not affected by it, so if the acceleration or retardation is not affected by it, or if the acceleration or retardation acting on the particle is 0, then there will be no change in velocity. So we can say the horizontal component of initial velocity, what is it? That is the ux. We can say u cos theta also will remain same throughout the motion, will remain same throughout the motion. This is the thing. Another thing that I want to tell you here, the vertical component, that is horizontal component, I am talking about the velocity now, okay, not any other thing. And the vertical component of velocity, that is the uy component of velocity, that is uy, that means u sin theta will be affected by g, that is the acceleration due to gravity or the gravitational pull. So now I want to separate these motions. Okay, here I am talking about the horizontal motion, that is horizontal motion is ux, that is u cos theta. It will remain same throughout the motion towards until it reaches the aim. This ux will remain the same and is constant or invariant of time. It does not depend on time. It will remain constant throughout the motion because the no acceleration or retardation acts on it. But in case of vertical, just see, when it is, I am saying about the uy, that is u sin theta, at each and every point on it, a equal to minus g is acting on it. Basically here I am separate this one particle motion. Which one particle motion? This one particle motion into two particles motion. Just like one is along this, another is along this. After that we just add up at the last. So if I saying only about the vertical axis, if I only about the vertical motion, at that time this is the positive y-axis obviously. Since u sin theta is along this direction, so it is increasing. U is positive along this axis, but the acceleration a minus g, it is the constant retardation acting on it, is acting downwards. So if it is acting downwards, so if the due to constant retardation acting downward due to the downward on this vertical component, so after some time it will be 0, and this is the ascent of it, and this is the ascent of it. If I say it is a t equal to 0, then obviously at t equal to t1 it will be here. Okay, that is the maximum height. We can say the height achieved by is, that is the capital H. That is the capital H. And after that obviously it will be not here. It will be not here obviously. After that momentarily rest, it comes down, but the positive x-axis remains the same. It is the y-axis. After it is coming down, say it is t equal to t1, its velocity is 0. Okay, when it again reach, not at that particular point but at the same level somewhere, I am showing you in that x versus y diagram, but before that you try to understand. When it reach there, the velocity is capital V, and when it reach here, say the time is capital T. So in coming here, the time taken by the particle is say t2. That is the time of descent. It is a t1 is the time of ascent and t2 is the time of descent, and capital T is the total time of flight. Now if I add up these two equations, just see. Here, this is the maximum height attained by the particle, capital H. Okay, and according to that, when the particle will be here, the time, if I say the time is t1. So after t equal to t1, due to the vertical motion, the particle will be at the maximum height, but due to horizontal motion, it is again each and every time it is pushes in this direction. So since it is moving upwards, its velocity obviously decreases, that is u sin theta, the y component obviously decreases, and its value decreases continuously, it is decreases and it becomes 0. But the u cos theta will remain invariant, it will be just like this. So if I want to say, if I say this is the vertical and this is the horizontal will remains the same. Here this is the vertical and this is the horizontal, and here the vertical component is 0, only the horizontal component remains. Horizontal component of velocity remains. After that, when again it is here, the vertical component just flips over. Now it is coming down, but the horizontal component remains the same. When it is here, the vertical component is like this, and but the horizontal component remains the same because it is completely unaffected. When it reaches here, again the horizontal remains the same, and the vertical component of velocity is same as that of the uy. Okay, why I am saying this thing? Because when the particle is projected with the velocity u sin theta, when it returns back, we know that it is u sin theta, but in that direction. So we can say the u sin theta becomes 0 due to ascending, and it again becomes u sin theta when again this t2 time elapsed, when it again comes to this level, it is not at the same point. This point and this point is not the same point. This point is the point of throwing, and when it comes back, it is at this point. Why it is? Because each and every bit of time the horizontal velocity acts on it. Each and every bit of time the horizontal velocity acts on it and pushes it towards these directions. But the vertical component of velocity will change from u sin theta. It gradually decreases and becomes 0, but the horizontal component remains the same. Okay, if I say from here to here, when it reaches the vertical component looks like this. It reaches here. Okay, and when it again returns back, the vertical component will be again becomes u sin theta. Just see it to this finger of mine and the pen simultaneously. When the particle is here, at that time the vertical component looks like this, reaches the maximum height. Okay, reaches the maximum height. After that, when it returns back, the vertical component, that is the time of descending, coming down. I'll show you again. This is the ascending, reaches the maximum height, again descending, comes down here. But each and every point of time, the horizontal component of velocity pushes it along the positive x direction. So the particle will be not at the same point again. So if I say that is the ux will remain the same. Each and every point, the direction of the ux, neither the direction, neither the magnitude, it is not changed. Okay. So from here, before doing the calculations of it, I want to say that analyze the motion. I want to write one thing, that is, in case of horizontal motion, what is the horizontal motion? It is the motion of a particle. It is the motion of a particle under constant velocity, and that is ux equal to u cos theta. Okay, because no gravitational effect, no acceleration due to gravity acts on it, because it is perpendicular. This motion, the horizontal motion, is perpendicular that of the direction of the acceleration gravity pointing. And in case of vertical motion, I want to write, in case of vertical motion, if I want to write the vertical motion, okay, in the time of ascent, that is when it is moving upward. In the time of ascent, the particle is under constant retardation, and in the time of descent, descent, D-E-S-C-E-N-T, the particle is under constant acceleration. Okay, and that acceleration is nothing but the acceleration due to gravity. So what we have done till now, we have just separated these motions into two equal halves. One is the horizontal and is the vertical. The vertical motion is first half is from here to here, from here to here it is under constant retardation, from here to here it is under constant acceleration, and it is independent of the acceleration, it is moving with constant velocity. The two motions are of completely different type. Thank you. And we will see these things, the equation of motions regarding to all of these things, in the next part of it.